And I'm going to see how many kids we have on the call right now. I will stop sharing my Dinosaur's name. We have a good number of kids, so I think we're going to get going. I see some smiling faces on the call, so that's excellent. Okay, so hello all of you junior paleontologists and dino enthusiasts out there. And welcome to the Mad Science Dino-sized adventure. This show is going to get started very soon. We have an amazingly fun hour planned for you. My name, as you can see, is Dinosaurus, and I'm a mad scientist. And I might be an expert at dino dancing, but I am not a dinosaur expert. But luckily, we do have a dinosaur expert with us. And to learn all about these prehistoric creatures, we're going to head to the Redpath Museum in Montreal, Canada, to meet our special guest, Alex, who is a paleontologist in training. He has been on real fossil digs and has amazing photos and videos and fun facts to share with you. Later in the hour, we're going to play a little mystery game. So if you can see these papers here, if you have your mystery game papers with you, that's awesome. If you don't, that's okay. We'll put the images on the screen so everybody can play along. So look out for that a little bit later. And make sure you stick around to the very end because we have a prize giveaway for one lucky winner. And everybody who registered is eligible to win. So fingers crossed it's going. Some technical tips before we get going. If you're having any issues hearing us or seeing us, we recommend that you try joining from another device if you have one handy. Now, since we can't show you real life dinosaurs, we're going to be showing you a lot of videos and photographs. We hope everybody has no trouble viewing these images. But if you do, the event is also being recorded and you can watch anytime after the event on our Mad Science YouTube channel. Now, this virtual meeting might be a bit different than the ones you're used to. Everyone is muted at the moment, so let me just double check that everyone's muted. Can everyone around the world let out a huge dino roar? Okay, ready? In 3, 2, 1. Okay, perfect. I couldn't hear anyone. I think I felt some vibrations, but I don't think I heard anything, so that's perfect. As well, because there's so many kids on the call, we only have space for a few cameras to be on. So if you can't see yourself, that's a-okay. As long as you can see and hear us, that's perfect. We do have a question section open at the bottom of your screen. So for those of you with your cameras off, you can still interact with us. You can type in your dino questions. You can say hi, you can tell us about your favorite dinosaur. We have a team of mad scientists to get through as many as we can, and we hope we can get through them all. Lastly, what is mad science? Now, some of you may know mad science from your local communities, but what you might not know is that we are the world's leading science enrichment provider for kids aged 3 to 12. We have a global reach of 150 locations in over 20 countries. Right now on the call, we have people from all over the world. So give a T-Rex wave to everybody else on the call. Hello, hello, nice T-Rex wave. We absolutely love bringing fun and educational science programs to kids. We do birthday parties, we do after school programs, we do summer camps, workshops, and virtual events just like this one. And lastly, we want to tell you about our very special mission because it has to do with kids just like you. We are on a mission to spark the imagination and curiosity of children by providing you with fun, interactive, and educational programs that help you learn more about science and how it affects your world. Okay, so I think that's it for me. I'm very excited to get learning about dinosaurs to improve my dino knowledge. And I am so happy to introduce you to my friend and paleontologist in training, Alex. Woo!
Thanks, Dinosaurus. All right. If you, so I think, yeah, you can probably hear me at the moment. So believe it or not, I may be a grown up, but I'm still at school and I still have a teacher, even at my age. And that's because to be a paleontologist, to study dinosaurs, well, you have to work pretty hard, and you have to stay at school for a long time, long after finishing kindergarten or primary school. But you will see a bit later what that kind of school is like. The school where you can actually learn about dinosaurs. Well, the way it's going to work is that I'm going to show you a video, but throughout the video I'll ask you questions, and you'll be able to answer them, probably in the chat because of the camera limitations, right?
A few kids might be able to raise their hand if I see their screens on their hands.
Yeah, and also one thing we also talked about earlier, if you think raising your hand is boring, you can try and make the impression of one of your favorite horned dinosaurs by just putting your fingers above your head like that, and that will probably get you noticed. Exactly, just like that. And so, honestly, before we start, I have to say I was very impressed by the number and the number of questions we got, and how good some of them were. It shows that a lot of you out there already know quite a lot about dinosaurs. I was pretty impressed, and so we won't be able to answer them all, I have to say, but we chose the ones that we thought would interest interest as many people as possible. So we'll go through those questions as we go. All right, so let's get this going. So the first question that I can answer at the moment right now is, do you dig for dinosaurs? Well, as you probably realize, the short answer is yes. And so without further ado, we'll get into exploring how we go about digging for dinosaurs here. All right, can you see my video?
Give a thumbs up if you can see it. Okay, I see a lot of thumbs up. That's perfect.
All right, we're good. So I do dig for dinosaurs, and for that I have to go pretty far away in a very dry and barren landscape that looks almost like the moon. And so normally every year at my school, at McGill University, my teacher organizes camping trips to Alberta in Canada. I'll show you later where it is on the map. And normally every summer, we just go out there and dig up dinosaur bones and bring them to the Redpath Museum. So Jen, can you just share your slides?
Yes.
Great. So at the moment, I'm in Montreal. So the red circle near the middle of planet Earth, where we all live. And every summer, I go all the way across Canada to a place called Dinosaur Provincial Park. Now, no prizes for guessing why this park is named after dinosaurs. You'll see much later. And what I've done is I've just written the names of the countries where all of you come from the information I've got. So pretty diverse group that's listening to this at the moment. And so if you go to the next slide, one question that I found pretty interesting among those that I received was, well, how do you know where to look for fossils? Can you just go in your back garden and start and with a shovel and start digging up the plants your parents planted? Normally, well, you should never do that, first of all. And secondly, it depends on the kinds of rocks that lie underground, that lie under the ground. And if basically wherever you have rocks that represent like sand or mud that got stacked over a long period of time, you might have a chance of finding dinosaurs if that sand or that mud accumulated at the bottom of like a river or a lake, so normally on land, because most dinosaurs at the moment, we're pretty sure they all live on land. And well, it would be very hard to just dig a hole in the ground and go like meters and meters deep to find bones. So normally it's much easier to go to places where wind and water just carve up the ground for us over years and years and years. And that's how some of the rocks some of the rocks lower down that would normally be underground, well, they get exposed, and you can just walk around and find dinosaur bones that are just coming out of the ground. If so, you can stop sharing, and I'll continue showing my video. So as you can see, Alberta in Canada is exactly that kind of place where wind and water just exposed a lot of rocks that were laid down millions and millions of years ago. So if you remember the little quiz, 65 million, there were dinosaurs 65 million years ago, and those were among the last dinosaurs. This guy here, the guy with the cowboy hat, that's my teacher. He's the one who's our teacher, not only in the museum, but also in the field. So to get to films like Jurassic Park, where we have a fairly good understanding of what dinosaurs look like, that we can actually depict them in movies and things like that, there's a lot of hard work that has to be done first. A lot of hard work, just finding the remains of those animals in the first place. Now, if Dinosaurus, I think it would be good to show the globe again, just to remind the kids of what we're looking at here. So try to keep that in mind. So Canada and the USA, those two countries are on a piece of land that we call North America. And if we can go back to the video, the thing is that the world was very different at the time of the dinosaurs. So this is the same, this is North America again. But what you can see, some parts are grayer, are a bit more gray, and another part is a bit more white. And this map basically shows that at the time of the dinosaurs, North America was split in two. That white patch in the middle, that was actually sea. The sea was basically hundreds of meters, maybe tens of meters higher than it is today. Like where I'm standing right now, I would probably be standing underwater at the time of the dinosaurs, if the sea were, if I were like at the same altitude and the sea were as high as at that time. And so, and to give you an idea of how long ago the bones we find in Alberta were buried, I can show you this. So today, so this is just a sort of timeline of the history of our planet. We live in the present here, and when we look for like extinct animals, which is the job of paleontologists like me, we often have to dig deeper into the ground. Like for mammoths, you don't have to dig up that far, but for dinosaurs, you have to go much further down, at least 65 or 66 million years further down. So the rocks at the bottom are the oldest, and the rocks at the top, the ones like in your back garden, they're the youngest. And so for dinosaurs, you have to dig fairly deep. Now, another question that I had was, how do dinosaur bones become fossils? I think it's the first time I've mentioned the word fossils. And so I'll just make it clear what that actually means when we say that a dinosaur bone is also a fossil. So I'll ask you a question now. Out of those two, both of those are bones, but which one is a modern bone, and which one is a fossil, the older bone?
I see some people with raised hands.
Yeah, and I'll stop sharing too. I'll stop sharing.
I'm going to go to Sarah Winchester. We can't see you, but I hope we can hear you. I'm going to ask you to unmute yourself.
I think that the red one, the brown one is the modern, or no, yeah, the modern one, and the white one is like a fossil.
Okay, we could try, maybe we could go for maybe one more answer.
Let me see. I'm going to go to Krista Luther. I'm going to ask you, oops, sorry. I'm going to spotlight you. That was my.
I think the dark one is the modern one, and the kind of white one is the old one.
Okay then. So I'll give you the answer. Unfortunately, it's the opposite. This is the modern bone, and this is the fossil. And well, the way you can tell is that the reason that this is the fossil is that normally when that bone first ended up in the ground, it was still white, just like that cow bone there. But what happened was that some of the rocks in the ground just got into the bone and replaced like the original material that formed the bone, just replaced it with a bunch of rock. And the color the bone gets during that whole process, which we call fossilization, well, it depends on the rocks in which it ended up, in which it was buried. So also, I'm going to ask you another question. So those two bones, those two bones are fit in the same part of the body, in the same skeleton. Like this one belongs to a dinosaur, but this one belongs to a cow. But basically, we have the same bone in our body too. So can anyone have a guess, like whether it's in the chest, or whether it's in the leg, whether it's in the neck, or does anyone have an idea?
I'm gonna look for some raised hands over here. Let me go to Emmy. I'm going to ask you to unmute yourself and spotlight you. Emmy, what is your guess? Can you unmute yourself?
I think it might be a fossil in the leg.
Okay, we can try one more guess, and then I'll give you the answer.
Okay, let me see. Does anyone else have a guess? I'm looking for raised hand. I'm going to go to Christina Henson.
Well, I think the white one is a dinosaur bone, and I think the brown one is a fossil.
Okay. Okay. So that was that was the first question, but now we were on to another question. I'll give you another try. So where in the body do you think do you think this bone or that bone fit? Like they fit in the same place, but where in the body do they fit? Do you think?
Well, the white one is in here.
Okay. Okay. I'll tell you where it fits. So both of those bones, they are the same bone as the one we have here in the upper arm bone. It's called the humerus. I can just write in the chat. Where can I do that? Yeah, I see a lot of people answered in the chat.
Oh, we don't have a chat. We have a Q&A. So
All right.
maybe one of our mad scientists can try and type it into the chat. But we'll repeat it again. It's called a humerus.
Yeah, the humerus. So the upper arm bone here. So everyone has a humerus too, just like dinosaurs, really. So pretty cool to say that you have something in common with dinosaurs. So with that, I think I'll have to continue the video. Oh dear, it's 1:24. Okay. So what exactly do we find in the field? How do we go there first? So you saw we drive all the way there. We have to get a lot of fuel, get a lot of food too, and then we go camping. I have to say that when I was a kid, I went camping a lot with my parents and my siblings, and it helped me a lot afterwards when I went out camping with friends and colleagues to look for dinosaurs. And I can answer more questions about about the details of camping later. So our campsite is located by a river, and we often have and one of the sites we work on is on the opposite side of the river. So you can imagine that we have to do a lot of canoeing just to cross that, and then after that we just go on a little hike. Lasts about maybe half an hour if we go fast enough. The return leg always lasts longer because we're full of dinosaur bones, and some of them are pretty heavy, as you will see. So often when in some cases we still have to dig a little bit into the ground, and that's where the really hard work comes in. Like if your parents ask you to shovel snow later when you're kids, when you're a bit older, you can take it as a learning experience in case you end up shoveling for dinosaur bones. You'll be grateful for it later. And so what do we find? So when I said that there are some places in the world where some bones just come out of the ground, that's how we find a lot of them. They're already, one side is already exposed, is already exposed to the air. And I think I can ask you another question now. So where do you think that bone would fit? And what kind of dinosaur, and where on the dinosaur's body do you think it fits? Yeah, so Jen, you can start, then get on the third slide.
Okay.
So we've got a lot of ideas here.
So I'm going to see if I can ask Rob Brown. I'm going to ask you to unmute yourself.
And maybe I can just, yeah, actually, I think you have to get on the fourth slide for that one, yeah, because it's, that's another one, yeah. Yeah, that one, yeah. Right, there we go.
Can you repeat the question? We have Rob Brown unmuted.
Yeah. So which dinosaur it belongs to, and where in the dinosaur's body that bone fits?
Rob, do you have a guess? I might go to someone else if I don't hear. Okay, let me just see if someone else. Going to look through the screens. I see Diana. I'm going to ask you to unmute yourself.
I think
Hi.
I think the dinosaur bone is a T-Rex leg bone, I think.
That's a good guess. Thank you
Okay.
for your guess. Did we want to take one more, or do we want to go to the answer?
Yeah, I think we'll go straight to the answer. We'll have to go and do that a bit faster. So yeah, you can just show the rest of the slide really. So first of all, that okay. In fairness to you guys, the photo wasn't great, but it's basically a big. What you see is basically a big spike, and that spike, it didn't belong to a Stegosaurus, but it did belong to a different kind of armored dinosaur. So in this case, it's a huge spike that would have fit like right on the shoulder of a nodosaur. So these are armored dinosaurs that did not have a club tail. You'll see an example of a club-tailed armored dinosaur. I think they're a bit more famous. But I mean, that's a pretty rare find. Normally, we just find a bunch of ribs and leg bones. So we were very excited when we actually found that kind of bone. So you can stop sharing, and we'll go back to the video. And so the next one, I think you'll have to get the next slide ready, for that. So we've got that one covered. How about this one? Okay, I'll stop sharing. So take a look at this. You'll see it on the slide anyway. Yeah. All right. So does anyone have an idea where that would fit in and what kind of dinosaur would have that?
So the question is what dinosaur and where on the body it would be. I'm going to go to Sharavari. I'm going to ask you to unmute yourself. I'm going to spotlight you.
Yeah, answer.
It's another one. Oh, I think it's a Brontosaurus hump.
A hump?
A Brontosaurus hump. That's a good guess.
Okay, I think we'll go to the answer, so we can show the next animation. All right. So the spiky thing there is pretty similar to the spiky thing right there. And so what we are looking at is you're looking at the nose of a horned dinosaur. It's not quite Triceratops. It's a bit different. It was a bit older and a bit smaller than Triceratops, and it was called Centrosaurus. And it's basically the most common dinosaur you find in Canada, really. We found thousands of remains of that particular dinosaur. One thing I want to show you is just how big that head was. Like most of you are probably like around that size. So that animal had a bigger head than most of the audience here. I think it's a great stat. I never presented to an audience and been able to say that kind of stat. And so horned dinosaurs were of all the animals that lived on land, they're probably the ones that had the biggest heads like ever. So with that, we'll go back to my video. And then how about that one? Oh, sorry. How about that one? That one looks pretty big, doesn't it? So for that, Jen, you'll have to go back to the third slide with the one with the same photo as this. Okay, we can see it here. So at this point, you might think it's pretty hard to identify some bones, and that's when I think it's good to answer a question that came up a lot: is how can you tell what dinosaur a fossil belongs to in the end? And so you can just show the rest of the slide at this point, yeah, because the photo isn't great anyway. So what you see here is a femur, and so the femur, humans also have it. If you jump to the next slide, it's the thigh bone. It normally is the biggest bone on most animals that live on land today. And again, you can see that we have the same bone as dinosaurs. And so if you finish the slide, basically the short answer is that it takes a lot of practice. You have to look at, the fun thing is that if you don't have access to fossils, to actual fossils, to look at them and to touch them, well, you can still go through, you still have access to a bunch of books where there are like so many cool images. Like that one, for instance. Wow, lucky me. I just ended up on a page where on the top right, you just see a bunch of femurs, those thigh bones. And then it allows you to compare the same bone, but for different kinds of dinosaurs. And that's where at one point you can tell that this femur belonged to one of the crested duck-billed dinosaurs instead of a horned dinosaur like Centrosaurus. So yeah, short answer is it takes practice in the field and in the lab. So we'll go back to my video then. So can you see? Okay, I'll go back. All right. What else do we find in the field? Well, we're not just interested in the dinosaurs that lived in Alberta, for instance. We're also interested in what their habitat looked like, what kind of trees grew around them. Were there any mountains, or were there any rivers, and what other animals lived alongside them? Yeah. By the way, does anyone know what this fossil is?
I'm gonna look for some raised hands. Let me see here. I'm going to go back to Diana because I don't see too many raised hands.
Ashley, my name is Faris. I think that's a leaf bone. I mean, leaf fossil.
Exactly. So and this leaf is very similar to many tree leaves you find today. So what that tells us is that yes, dinosaurs look very alien to us, and that's what fascinates us about them, I think. But you also had a lot of other things that would have been very familiar to us at the same time. At least the last dinosaurs, they would have lived alongside broad-leaved trees, like things like oaks and maples and sycamores and relatives. Does anyone know what that is?
Any guess is a good guess, so let's see some guesses.
What kind of animal?
I'm going to go to Saskatchewan.
I think it is a crab, like an ancient crab fossil.
Okay, so it's still an aquatic animal, but it's not a crab. It's what you see here is a head, and then you see 1, 2, 3, probably 4 legs somewhere, and in the middle, that's basically a carapace, a shell. And so maybe someone has, maybe we can take one last guess, just to, because I almost gave it away there.
Yeah, sure. Let me see. I'm going to go to Rohan. You can unmute yourself.
So I think it's a turtle. And when we first guessed the dinosaur, wasn't the first one a mummy dinosaur?
The first one, what do you mean by the first one? Oh yeah, oh yeah, one of the photos. Yeah, you'll see it later. I think I know what you mean. Yeah, I'll show it. I'll show it later during the Q&A. It was the Nodosaur, I think. But anyway, you're right about the turtle. It is a turtle, yeah. And we also find bits of turtle shell. And sometimes we find complete turtles, but most of the time, honestly, that's all we find from them. Yeah. So you know, we find big bones, but then we also find smaller remains. Like, does anyone know what that is? I think there's plenty of raised hands.
Yeah, I'm going to go to Anika. I'm going to ask you to unmute yourself.
All right, it's either a claw or a tooth.
Okay, so yeah, so we're pretty close to we're pretty close. So I'll just tell you what it is. This is a bit of broken Tyrannosaur tooth. So pretty big, yeah. So pretty big. It's not like, contrary to popular belief, it's not quite like a knife. It's much thicker. It's more like a drill, really. So imagine an animal with like maybe 50 teeth of that size in its jaw. Pretty scary, I'll give you that. So, okay, so we'll keep going then. And then I can also just answer one of the questions too. So someone asked me, or a few people asked me, what was the coolest fossil I ever found? Well, I'll show it to you then. I did find it in Dinosaur Provincial Park here in Alberta. Now that's very hard. So that one's very hard to guess. We had to actually look into a book to make sure we knew what it was. So what you see here would have fit on top of the head of a tyrannosaur, a smaller tyrannosaur, really. So the head, the bone in the head is actually a lot of bones. The skull is made up of lots and lots of bones. So that's just a bone that lies on top of the head of a tyrannosaur. Like when I found it, I think I guessed it. I think I guessed it belonged to that kind of dinosaur. But when we confirmed it in the book, I was just very happy at the end of the day. So at this point, I'll let the video run for quite a long time, because then you'll see, once we find dinosaur bones, how do we actually collect them? So often it's very hot. So you have to drink a lot of water, I have to say that. Once you find it coming out of the ground, you just have to scrape some of the earth and the sand off. And eventually a bigger surface of the bone will be exposed. I saw questions where like people ask me, you know, are they fragile? Are they heavy? And the truth is, they're still fragile, because they're so fragile that actually you have to build, for some of the bigger bones, you have to make a cast in the field, just as if you had a broken arm, a plaster cast. So what you see here is we made the cast out of basically sheets of burlap, and then you dip it into a mix of water and plaster. And those together form what we call a jacket. So a jacket is the word we use for a cast for a dinosaur, for a big dinosaur fossil. So what you see at the moment is we're just adding lots and lots of layers of that mix, and you never have too many of those layers. If you put 3 or 4, and it makes a jacket, and it makes like a jacket that's about that thick around the bone, and in this way, well, when we have to carry it out, often over like real long distances, it protects it, it prevents it from breaking. What you see here is that after the first layer is put, well, there's a side that we haven't got to yet. So we have to flip the bone plus the rock around it. Sometimes we make a little mistake, and when we flip the bone, well, some of the rock just comes off, and then you end up having one side of the fossil still exposed. And well, we don't want that, because well, that means there's a chance it might break while we carry it. So the guy in the middle, wait a minute, I'll just go back there. The guy in the middle, what he does there, he puts glue all over the bone, and that glue just sticks everything together. Also, what's important is that is also to just to do a lot of notes about where each of the bones were found, because eventually, what you can do after that is just draw a map of where each of your bones were found for a given area. I'll just stop sharing for a moment. I'll just show you an example of what a map of a dino fossil site can look like. Is that it? That's the one. So you can see a lot of little shapes that I drew there, and so this is in there, and then each of the squares represents an area maybe the size of a small table. And so you can see that we found that in this place in particular, close to Alberta, we found quite a lot of dinosaur bones, and the fact that we took notes about where we found them enabled us to do this to draw this kind of map afterwards. And that can tell us, for instance, how those bones all got together, and that in a way can tell us how some dinosaurs died. So I'll show you this. I'll share my screen again. So once we get the fossils, once we drive across all of Canada back to the museum, what do we do with them? Well, we bring them into the museum. Some of them are harder to bring than others. Like this jacket is huge. It's as big as your dining table, and basically it contains the part of the body of a rather big duck-billed dinosaur, and it's so heavy that, well, we couldn't just lift it up. We had to drag it. We had to put it on a cart with wheels, and then we had to slowly pull it on its wheels over a custom-made rail and into the Redpath Museum. But most of them aren't as hard to carry. Now, this is the basement of the museum, and that's where our fossil lab is located. And this is where I spend a lot of time just opening all those big plaster casts, those jackets, so that I can finally see and look more carefully at what we actually dug up. For example, there's a rather big bone. It would have been about that big, and you'll see, and then there's another big dinosaur bone there. And you'll see a bit later which kind of dinosaur they belong to. As you can see, there's a lot of plaster that I have to get rid of first. There's a lot of bones in there that I haven't looked at yet since we brought them back. Some of you may remember that's the nose of that horned dinosaur again, but viewed from the other side, the side that you didn't see in the field. That's basically a rib, except that rib is basically that long, so pretty big rib. Makes for pretty good dinosaur steak. And then, okay, honestly, I think we'll just go over that quickly because time's running out. So for some of those bones, I had to use a little dentist drill because the rock that I have to get rid of is very hard. And you know, I have to wear earmuffs. I have to wear, and then also, once you scraped up all the dirt from a bone, then some bits, sometimes they're still broken. And so you have to put some glue. So that's a much stronger glue than the one you saw in the field. We only use it in the lab, that one. And basically you can't pour water over it. Once the bond is made, it just stays there. That's when you know you use that glue when you know that you don't want to touch that anymore. I'll give you I'll show you. You may remember this is the same bone, and I glued that bit a few weeks ago, and as you see, well, the bond is still pretty strong. So that's important because all the bones we bring back, we want people to be able to study them like for many years after. Like people like you, when you become grown-ups, if you ever want to work on dinosaurs, we want those bones to be in as good a state as when we found them. Also, yeah, there's a question I forgot to ask. What kind of tools do you use? So I kind of started on it, but most of the time to get dirt off bones, I just use that little drill there. You just rub it off the rock carefully. That's a little pipette I use for some of the glue. That's a little brush I use to brush off like some of the more sandy rock off the bone. When I go into the field, I bring this rock hammer there, and that's pretty handy just to take off like big chunks of rock at the start when you still have to dig a little. Yeah. And when it's hot and sunny, very important to wear a hat and also sunscreen. But if I go back to the video. So once bones are prepared, then we can conserve them in museums for a long time for other paleontologists. By the way, do you know what dinosaur this belongs to, and where in the head it would fit? So that's one. So that's the. I have to get the slide here for that.
Nope. Sorry. Just have to go back.
Yeah, just yeah, that one. Yeah, perfect. All right.
So we're looking for what dinosaur this belongs to. I'm looking for some raised hands. I'm going to try and go to someone who hasn't answered as yet. Let me go to Gabriel. Hi, Gabriel.
Hi. I think that dinosaur bone belongs to a T-Rex.
That's a good guess.
Okay, yeah, fairly good guess. But we'll jump to we'll jump to the next slide, and actually, it's the head of a Parasaurolophus, a pretty well-known duck-billed dinosaur. Would have probably eaten lots of plants. So if we go back to the video, I'll just show another bone that's another real bone that's kept in a museum.
I think because we're running out of time, we might have to skip a bit ahead, but we'll see how far we can get. Don't forget to stick around because we are going to be doing a prize giveaway later on. Just some quick updates because we're running out of time. We won't get to do the mystery dinosaur sheets, but at the end, I'm going to put them on the screen. And we'll have the answers on our Facebook page. So once Alex stops his video, we'll give you more information.
Yeah, honestly, I think I'm just going to stop the video at this slide and try and have them guess again, and then after that, I'll just jump to the Q&A. Really.
Sure.
Okay. So. One last guess, one last identity guess. I'm holding the same bone in my hand here.
Okay, so I'm going to go to Pokemon.
So what's the question again?
What is that?
So, what dinosaur this belongs to, and where on the dinosaur it fits.
T-Rex.
And
Teeth.
where on the T-Rex does it fit? Which part of the body does it fit on?
His teeth.
Well, that would be a pretty big tooth. It would be pretty scary, but unfortunately, it does not belong to a T-Rex. You can go back to the Centrosaurus slide for that one.
Yep, let me just quickly go back.
So yeah, perfect. So it's our friend Centrosaurus again, but this time, what you see is basically a piece of the frill, the big round part at the back of the head. So it would be that part of the head of the Centrosaurus. So again, it's a pretty unique part of that dinosaur. And so when we find that kind of bone, well, we're pretty sure it belonged to that kind of dinosaur. So yeah, unfortunately we're running out of time for the rest of the video, but you've seen what it takes to bring a dinosaur from the field and into the museum, and eventually well, we can make replicas of some of the bones and show them to the public. And so I'll end the video now, and we can go to
what I'm gonna do, for those of you who have to leave us, I think Alex can stick around for a little bit longer to answer some questions. But for those who have to leave, I will do the prize giveaway now. So let me just show you the prize giveaway. It is not your dinosaur name. It is a Loop Lab prize. So what we have here is a STEM subscription box. Oop, let me go back. And we have everyone's name in a hat. And I'm going to choose the person. I'm raffling through. We have 3 boxes here, so our lucky winner will get all 3. We have a gross science box. We have, sorry, keep flipping. We have a spy science box, and we have a sensational science box. And the winner is Jessica Osagueda. Hopefully this is in the correct order. So Loop Lab is Mad Science's STEM subscription box. And it lets you bring science home to you if you can't get enough of Mad Science from your classrooms, from your birthday parties, from your camps. We would like to bring science into your home. So the lucky winner will get those 3 boxes. And we'll be emailing you right after to get all your details. If you don't already follow us on Facebook and Instagram at Mad Science Group, you can keep an eye on our pages for more free live events. Our STEM subscription box, I believe, is shop.madscience.com, so you can find out more about how to bring Loop Lab into your homes there. So quickly now, I will also share my screen to show you the mystery dinosaur activity sheets. We're really sorry we didn't get to this. The time went so quickly. Oops, sorry, let me go back. I will minimize this so you can see the screens. So Alex taught us a lot about what paleontologists do. We don't have smartphones and photographs of what dinosaurs looked like in the past. So as Alex said, it takes a lot of practice. So what we have here is some mystery dinosaurs for you. So you can draw the outline of what you think the dinosaur looked like. You can predict the color it was. You can look for clues as to whether it was a herbivore or carnivore or omnivore, maybe by looking at its teeth. You can take a look at the type of bones in the legs to see if it was a land animal or a water animal. So we will give you the answers on our Facebook page. Check that out. And I will stop sharing now. And for those of you who have to leave us, we're really sorry to see you go. And for those of us who can stay, we will be answering some Q&A questions for you. So I will look for some raised hands at the moment. Thank you so much for joining us for those of you who have to go, and we will see you next time. Okay, so some questions that we have. From what you saw, do you have anything to ask our experts? I'm going to go to Max. I don't think we've heard from Max's yet. Gonna ask you to unmute yourself. Oh, sorry, my computer's just a little bit slow.
So my question is that how could you tell if a fossil belongs to the white dinosaur?
So how can you tell if a fossil belongs to the right dinosaur? So how do you know which dinosaur is the fossil?
Yeah, so yeah, that's a very good question. As I said earlier, it just takes a lot. I think a lot of practice. You have to look at quite a lot of like complete dinosaur skeletons where you see where all the bones fit relative to each other. So that you know, for instance, that eventually this arm bone belongs to like one of the duck-billed dinosaurs like Parasaurolophus instead of one of the horned dinosaurs like Triceratops, for instance. So often I have to say that even before visiting museums, a lot of books, a lot of reference books have a lot of nice images that allow you to compare bones that belong to different dinosaurs. Like there are lots of images that show you like what the thigh bone looks like in one of the big long neck dinosaurs compared to T-Rex or Velociraptor. So that's usually how you do it, I would say.
Okay, I think we have some more questions. Let me go to Maya. I've seen your hand raised a few times. Hi, Maya.
Is there any good places to find dinosaurs in Ontario?
Ontario. So that's a good question. Normally, most of the rocks you find in Ontario, they're a bit too old to contain dinosaurs. Those rocks were formed before any dinosaur existed. There's only one place that I know of that would be the right age, where the rocks would be the right age to find dinosaurs. But so far, at the moment, we found plants. We found remains of plants, like some of the leaves I showed you, but no traces of dinosaur or any other animal for that matter. You have to go a bit elsewhere.
For those of you who don't know, Ontario is in Canada.
It's between here and like Alberta.
Okay, let me see if I can see some more raised hands. Hopefully you guys have the same questions in the Q&A field. I'm going to go to Paula Sanchez.
I have two things. One, remember that park you mentioned at the beginning? The park that you showed on the map? I think that's where they filmed Jurassic World. Is that correct?
So in those films, there's always this. Yeah, what's that noise? In those films, there's always a scene at the beginning where you have a paleontologist digging up bones. Like in the first Jurassic Park, the very first one, I remember there's a scene like that, but I can tell you that was shot in the USA, in Montana, a bit further south. Yeah, but and those actually were, that's actually a place where they probably filmed that where in areas where you could actually find some of the last dinosaurs like T-Rex and Triceratops. So a bit later than the dinosaurs that we find in Alberta.
Okay, I'm going to go to someone else with a new question because I think we can only have one question per person. So let me see. We can't stay on for much longer, but I think if Alex gives me the thumbs up, I might be able to take one or two more questions. Let me see here. I'm going to go to Tyrannosaurus Rex, who has their hand up and I know has been playing with dinosaurs this whole time. So let me see. Do you have a question for us?
Dinosaurs have feathers?
The question is, did dinosaurs have feathers?
No, did Megalosaurus have feathers?
Oh, Megalosaurus.
Okay, that's a very good question. We can't say no. We can't quite say yes either. The thing is that we find more and more remains of dinosaurs where feathers are also preserved around their bones. But most of those dinosaurs, they're like very small predators. They imagine like something the size of a chicken, but with teeth and a long tail. Like we now know things like Velociraptor would have had feathers. Now, for bigger carnivorous dinosaurs, at the moment, there's only a few of those where we have found traces of like small fuzzy feathers. Like I know of an older relative of T-Rex in China. A few of them do have traces of feathers. Megalosaurus, though, that's a much older dinosaur, and the way its fossils were preserved, it wouldn't allow for soft things as feathers to be preserved anyway. So that's a problem. We can't know for sure. However, there's still a possibility that all carnivorous dinosaurs had feathers. The question is just that the environment where they die, whether it allows for softer things than bones to actually make it to a fossil state. But yeah, I mean, there's still a possibility that because some dinosaurs had feathers and because some of the flying things, the pterosaurs, also had feathers, there's a chance that there is a chance that even some of the oldest dinosaurs still had feathers, that their common ancestor also had them. Yeah. So basically, the short answer, we don't know yet. We don't know yet, and it's still possible. Yeah. It's possible the young ones had feathers, the babies, and that as they grow bigger, it's easier for them to stay warm. And in that case, it would make less sense for a bigger animal as it grew to still have like that dense fuzz, a bit like a little chick. Yeah. So that's a really good question, and I don't think it will be resolved in many years. So there's plenty of time for some of you to investigate that.
Maybe you'll find out if you become a paleontologist when you grow up. Maybe you'll find out the answer and tell it to us. Okay, yeah. I think we have time for one more question. I'm going to try and choose somebody who hasn't.
And we still have time to just do what we discussed too at the end.
Yep, for sure. Okay, so I'm going to go to Triceratops and someone else. I can't read it fully. It's a little bit blocked.
What's your favorite dinosaur?
Oh, yeah, I'm glad you answered that one. I have a slide ready for that.
Okay,
the last
slide. Just go to the slide.
You'll see. I don't think many of you know that dinosaur. It's a really weird one. I had a bunch of slides ready for some other questions.
We missed a lot, but that's okay.
There was the mummy. Yeah, sorry. No, I'll do that. So, okay. If you go to the next slide. Okay, if we stop there. So I think this is my favorite dinosaur. So that one's called Dinosaurus. So Dino means terrible and Kyrus means hand. And you can see why it had that name. Like, I mean, look at those hands. They're huge. This is clear. This is no T-Rex at all. For a long time, that was all we knew about that dinosaur. And people, it was reasonable to think that it was a big predator, that it ate meat. I mean, what would those huge grasping hands be for, really? Otherwise, but then, if you continue, more of the skeleton was found, including a really weird skull with no teeth at all. So it probably couldn't hunt other dinosaurs. It didn't even have any teeth, and it had that weird sail on its back, a bit like Spinosaurus. And so that, I don't know, the reason I think this is Dinosaurus is my favorite dinosaur is that no one could have predicted how weird it was. And it's the kind of animal that shows you just how diverse dinosaurs really were. You had big ones, you had small ones, you had horned ones, you had spiked ones, and then you had toothless ones, but that still had huge arms. So what was also weird was that it was preserved in such a way that you could still find remains of fish in its stomach. So you can imagine maybe it was a bit like a pelican or something, or that just grabbed fish in the water with its huge arms and then gulped them. But at the same time, it may have eaten plants too. So a really weird diet on top of that. So yeah, so that's why I think I prefer the really weird dinosaurs in the end. And with that, also one really quick thing I could say: what does it take to become a paleontologist? Well, at the moment, I would say that the one thing really is curiosity. If you want to learn about anything, just go for it. just go for it. And you never know where that could take you, really. And with that, since we're really running out of time, there's one last thing we want to show you. So at the moment, I'm sitting in my office, but my office is actually in the Redpath Museum. I didn't make that very clear to you, but I'll prove it to you.
So we hope the Wi-Fi will stay for this. Alex is going to bring us on a live journey with a very special surprise at the end.
Yeah, I'll just show give a quick view of the gallery. So this is the top floor of the main gallery of the Redpath Museum. Can anyone see the Triceratops skull in the middle there? So that's not a real skull. It's just a replica, and that replica was actually cast in the museum, in the basement. And that's it. And the bones that were used to make that replica, they were actually collected by my teacher and some of his first students more than 10 years ago now, before many of you were born, really. That guy there. This is, okay, I'm gonna say it, it's not exactly a T-Rex. It's like his little cousin. It lived a bit before T-Rex. It lived in Alberta. It's called Gorgosaurus. And that's the kind of dinosaur that we find on our field trips. So honestly, that's all I'm gonna show you for the museum, because, well, we all have to go on. We'll have to go on for the rest of the day. But this was just a quick glimpse of how cool our museum is. It's a fun fact. It's the oldest natural history museum in all of Canada, but it's also one of the smallest now.
So we want to thank you guys for sticking with us to the very end. If we didn't get to all of your questions, we encourage you to keep researching. You can find out maybe your answers in books, on the internet. And we want to say a very special thank you to our expert, Alex, for all of his time and for sticking with us an extra couple minutes. And we are going to have you hold up all of the dinosaur toys that you brought to say goodbye to us, and we will unmute everyone to say bye. I will unmute you all in 3, 2, 1. Show your dinosaurs and say bye. Bye. Guys, bye.
Dingo.
You like my dinosaur, Pooh?
Yes. Bye.
Unique dinosaur.
Bye-bye, thank you.